The origin of life is one of the deepest mysteries in science, but the clues to solving it have been buried by plate tectonics, the water cycle, and even life itself. For answers, scientists are looking beyond Earth to primitive asteroids like Bennu, the target of NASA's daring OSIRIS-REx sample return mission. Now, material from Bennu is revealing a lost world from the dawn of the solar system, with the right conditions to foster the building blocks of life. When scientists examined the Bennu samples, they discovered evidence of a wet and salty past. Among the dark rocks were bright veins of salts that form on Earth when brines evaporate from alkaline lakes. Searles Lake, California is home to a mineral called trona, which is mined as a source of baking soda. Scientists found microcrystals of trona and other evaporite minerals within the Bennu samples, indicating that they once held pockets of sodium-rich water. Such brines are ideal for cooking up organic molecules, carbon-based compounds that are the stuff of life. Bennu is a carbon-rich asteroid, and its samples are chock full of organics, including amino acids and nucleobases. Amino acids can be bonded together in long chains to build proteins, which give cells their structure and function. Life is constructed from a set of 20 amino acids, 14 of which were identified within the Bennu samples. Nucleobases are the genetic components of DNA and RNA. All 5 nucleobases were discovered in the Bennu samples, a first for extraterrestrial material collected by a spacecraft. In addition to organic molecules, scientists found that the Bennu samples are surprisingly rich in ammonia. On Earth, ammonia is a common agricultural fertilizer. It readily evaporates at room temperature, but is more stable in cold environments, like those found in the outer solar system. Bennu is too close to the Sun to retain pure ammonia, so its samples must have formed during a more distant, frigid past. Salts, organics, ammonia. Thanks to OSIRIS-REx, we can now piece together these clues to tell a likely origin story for asteroid Bennu. 4.5 billion years ago, in the nascent solar system's outer reaches, a world of rock, metal, and ice took shape. Radioactive decay heated its interior, melting some of the ice. Pockets of mineral-rich water reacted with formaldehyde and ammonia to produce organics. As the water dried up, the dissolved minerals crystallized, leaving bright veins within the rocks. The world migrated closer to the Sun until it was shattered in a collision and destroyed. Bennu accreted from the rubble and drifted further inward, eventually settling into a near-Earth orbit where it could be reached by OSIRIS-REx. Our planet was bombarded by asteroids like Bennu early in its history, suggesting that many of the same organic molecules were present on Earth before the dawn of life. These findings help to close a gap in our understanding of the early solar system, but key questions remain open. Many amino acids can be created in 2 mirror image versions, like a pair of left and right hands. Life on Earth almost exclusively produces the left-handed variety, while the Bennu samples contain an equal mixture of both. This means that on early Earth, amino acids may have started out in an equal mixture as well. The reason that life turned left instead of right remains a mystery. Additional insights may come in 2030 when NASA's Europa Clipper mission arrives at Jupiter. It will hunt for evidence of a briny ocean within the moon Europa, an environment favorable to producing organics. Until then, scientists will dig deeper into the Bennu samples, unearthing more molecular clues about the origins of life.